Hey there, scientist. Today, you are going to think like an engineer and make observations. Your goal today is that you can design and test a method to reduce the rate of erosion on a hillside. You are going to use evidence from your test to defend the effectiveness of your method for slowing the rate of erosion. So, what we're asking you to do here is we're asking you to think about what you have learned so far about weathering and erosion. So, what are some examples of weathering? Rocks or sidewalks that have been cracked, rocks that have been worn smooth. Those are examples of weathering. Weathering is the breaking apart, the wearing away, or the dissolving of rock into smaller particles called sediment. Well, if that's what weathering is, what's erosion? Erosion, such as the way soil moves in a riverbed or down a mountain in the rain. Erosion occurs when sediment is picked up and moved to a new place. So let's look at this picture we have in front of us. Is this a picture of weathering, or does this photo show erosion? You're right, this photo shows erosion. We can see that there's water on top of this field, and the rainwater, the water is pushing it all this way. And we have all of this sediment that has been moved to this place. Well, that is going to show erosion. Too much rain can erode the soil in which crops are grown. You have read how running water can change the shape of the land. Now you'll use what you've learned to help solve the problem. So today is all about problem solving, and it's all about your solutions. So on this land right here, what factors might affect the rate or the speed of erosion? Well, it could be the amount of rainfall, that's right. It could be the slope of the land. It could be the way the land is plowed. It could be what's covering the land or what's growing on the land or what's not growing on the land. All of those things could be part of the problem of what's happening here with erosion. If we jump back to our text, after a heavy rainstorm, a farmer discovered water making gullies in the soil. Water was eroding the soil as it made its way from a field to a nearby stream. If this continued, much of the soil would be washed away. Then the farmer would not be able to grow crops in the widening gully. So you are being asked to solve the problem of the soil eroding from the farmer's field. You will need to test your solution. You will need to use a small scale model to investigate the rate or the speed of the erosion. So you are going to be an engineer, and you are going to be looking for a solution. Now, remember, we're looking for a solution to our problem. And what is our problem? Well, our problem is, how can you slow or prevent the erosion of a farmer's field? So we have this farmer's field here. How are we going to slow down them losing their topsoil? Because if they lose all those amazing nutrients in that soil, it's going to be a lot harder for plants and crops to grow. So we have our problem defined. Now we need to start looking for solutions. Now, when you start looking for a solution, this is the big thing that you are going to do. To solve this problem, you will need to make a model of a hillside. You are going to decide on the materials you will need for this model. Ideas might be, maybe you're going to use a plastic tub, and you're going to put your field and some dirt inside of that tub. Maybe you're going to use a baking tin, a baking sheet. Maybe you're going to build a form out of wood. Maybe you're just going to use a space that you have outside where you could build up some dirt. But you're going to have to figure out what are the materials you're going to need in order to be able to replicate this environment in order to test for possible solutions. You are in control of your materials. Your teacher might have some materials that they want you to focus on and focus with, but you have to make certain that as an engineer, you know what you need in order to be able to help the farmer solve this problem. So after you build your hillside, you will need to decide on how you're going to measure the rate of erosion. What are some ways you could change how the water flows down your model hillside? Which variables will you change when you test your model? Which variables will you keep the same? How will you know if the tests you run are fair? So you're going to be conducting this experiment at least twice. And you're going to have one system where you have controls, things that you're not changing, variables that you're not enacting. So a fair test is one in which you're going to change only one thing. So you need to understand that the variables that must be controlled or kept the same is the amount of water poured on the field and the speed or the rate at which it's poured. Other variables that you're going to want to control is you're going to want to control the size of your field. The field should be the same size in both of your investigations here, where you build your first field and then you make a modification to that second field that looks exactly the same, but with a modification to see if you can slow or stop the erosion. You're going to want to make sure that your slope or how much your field is tipped to create runoff, that is the same in each of your tests, because we have to have some controls so that we know whatever you're doing to the field, if that really is stopping the erosion. And again, you have to ask yourself, how will you know if the tests you run are fair? You are going to write out a plan for your investigation. You're going to include a diagram of your hillside and the solutions to reduce erosion that you test. Then you're going to collect all the materials you need and you're going to build your model. In your assignment, if you need to add an additional page in order to have your plan in there, or to take a picture of your plan that you write on a different page, you can add to your assignment in order to have all of the pieces that you think you need, depending on what changes you're making and how you are recording your information. So you have everything set up. You are ready to test your solution. So when you test your solution, you're going to carry out the test as you planned it with your controls in place. And you need to collect the data from your test. How did you measure the amount of erosion from one field to the next field? Like, what was it that you noticed and changed? How did you know that there was more or less or a different amount of erosion? And you may need to repeat your test several times, changing the variables you identified in your plan, and then record your observations. So maybe the first time you put the water on and it goes very quickly and you have to rerun your test because it didn't match your first test when you added the water to create the erosion effect. Now, after you tested your solution, you are going to refine or change your solution. You're going to look at your data and you're going to say, did your solution change the rate of erosion? So whatever you did to the second field, did it make it erode slower or less, or did it stop the erosion altogether? And did each trial produce similar results? Did changing the variables you identified in your plan produce a better result? Could you make your solution work better? And then test those new ideas. So as an engineer, you are continually working to figure out the best process to make the best solution in this erosion scenario. When you are satisfied with your solution, get ready to explain your plan to others. Draw a detailed diagram or make a poster of your solution. Include clear labels that explain how your solution will work. Be prepared to defend your solution as others question or challenge your plan. Plan your argument in detail. Be sure to provide evidence from your test to support your solution. And there is a spot in the assignment where you will upload a picture of your plan, of your poster that shows what your process will be to reduce erosion. You're going to share your solution and you're going to record their comments and suggestions. Now, then you're going to evaluate those comments. Which of the suggestions would improve your plan? And then how could you revise your plan to include the suggestions? This is the process of an engineer. You're constantly revising and changing to make certain you have the best possible scenario. When you are satisfied that your solution is the best you can make it, revise your presentation, then you're going to share your solution out. Sharing your solution might just be you turning in your assignment to your teacher. Sharing your solution might be you in a breakout room sharing it with other classmates. Sharing a solution might be you at home with a family member and you talk to them about what you did to make this process different. When you are done with this, you are going to have to answer a few questions. Like, what is a fair test? Are you positive that your experiment, your investigation, your engineering process here, are you positive that it only tested one thing? Or did you have too many variables? And then when you designed your test, what was the variable that you changed? And what variable did you observe or measure? What variables did you keep the same? So we really have to know, how did you guarantee as an engineer that this is a fair test? This is a really fun and it's a really interesting assignment because you are the one who is creating the experiment and the investigation. You are making your own observations based on what you do to the environment. So your results are dependent all upon your ingenuity, your creativity, and your critical thinking. And when you're done, you will be able to say that you designed a test and a method to reduce the rate of erosion on a hillside, and that you have evidence from your test to defend that effectiveness of slowing the rate of erosion. Really enjoy this one. Dig deep, think critically, be a great scientist here, and enjoy.